Hello, welcome to this channel. So today I want to show you how to balance half reactions. So have you seen? I've put an example here, so we have to consider this one. So the first step that you have to do is to split these reactions. So I'm going to say, right? So let's do with this one, then we'll deal with the other one. So as you've seen, we've split this one to this one because this one is containing the things, the elements that are alike. So we can't get this one and this one, no, but we have to get this one and this one. Okay, so when we do this, what we have to do first is to balance the atoms, right? So we have to balance the atoms first. So here we have two iodine atoms, but here we have one, so we put a 2 here, right? So once we put a 2 here, we will discover to say we have 6 oxygen atoms. So to balance the number of oxygen atoms, we have to add water molecules, right? So we have added water molecules in order to balance the oxygens, right? So always remember, add water molecules in order to balance the oxygens, right? So I've put a 6 here because here we have 2 times 3, which means 6 oxygen atoms. So the oxygen atoms have been balanced while the hydrogen atoms are not balanced. Here we have 12 of them, 6 times 2, but here we have none. So what we have to do is to add 12 hydrogen ions. So when we want to balance the hydrogen atoms, we have to add the hydrogen ions, right? So the number of atoms have been balanced, but one thing that is not balanced, the charges, right? So here we have 0 charge, but here we have 12 minus 2. We are saying minus 2 because here there is a 2 and here there is a negative. So what we have to add is the electrons. We are going to add the electrons on the side which has many positive charges. So 0 is less than what? 12 minus 2 is what? 10. So 10 electrons. So that when we say 12 minus 2 is 10, 10 minus 10, that is 0. So the charges have been balanced. So the number of atoms have been balanced here, and also the number of charges have been balanced. So we have dealt with this half reaction. So since we are done with this one, let's do this one as well. Let me do this. Okay. So when you look at this one, what you're going to discover is that here we have 3 oxygen atoms and here we have 2. What we have to do, we add water molecules. So here we just have to add 1 because here there are 3 oxygen and here we have 2 plus 1, which is 3. When we add this water molecule, discover to say the hydrogen atoms here, there are 2, but here there is nothing. So what we have to do is to add 2 hydrogen ions, right? So the atoms have been balanced. The nitrogens are the same here on this side, the hydrogens and the oxygens. So one thing that is remaining is what? The charges. Here we have the difference of 1 charge, 2 minus 1. Here we have 0. So we add 1 electron, right? So we have 2 half reactions, this one and this one. So what we have to do next is to cancel these electrons, and we cancel them if they are not balanced. So we are going to multiply these reactions by a factor that is going to make these guys equal, this one and this one, and it is actually 10. So when we multiply with a 10, we are going to discover that this one will... So that is why I cancelled this one and this one. So another thing that we have to consider is that here we have 6 water molecules and here we have 10. So these water molecules, since they are on opposite sides, we are not going to add them but to cancel them. Here they will disappear, but here we are going to remain with 4 water molecules, right? Now, here we also have 20 hydrogen ions, but here we have 12, right? So the difference between 12 and 20 is 8. So these guys will disappear and here we are going to have 8, right? So when we have 8 of them, what we have to do is to write the things that are remaining, right? So let's say iodine molecule is remaining on this side, right? This is the overall of this reaction, and the overall of this reaction is you've seen? Yeah. So this is the overall of this reaction and the overall of this reaction when we cancelled. Now what we have to do is to combine this one and this one, meaning everything that is on the left side and everything that is on the left side on this one will be put together, right? And everything on the right and on the right are going to be put together, right? So let's get it done. We have this one, then plus 10 nitrate ions plus 8 hydrogen ions is equals to so when we see this one, what you're going to discover is that we have actually balanced this one under acidic condition. So for us to prove this one, we have to consider the number of atoms. Look at this one. Here we have this one. They have balanced. Nitrogen, 10, they have balanced. Right? Oxygen, here we have 10 times 3, that is 30. Here we have 2 times this one, that is 6. 6 plus 20, 26. Plus 4, 30. Hydrogen, here we have 8. Here we have 8, right? They have balanced. What about the charges? How many charges do we have here? Here we have 8, right? Minus 10, that is minus 2. What about here? We have minus 2. So the charges and the elements have been balanced. So we have balanced this one under acidic condition. So now, what if they told us to balance this one under basic conditions? So if they told us to balance under basic conditions, what we only have to do is to add hydroxide ions on both sides. So when we add hydroxide ions on both sides, what we are going to have is this one. Plus 8 hydroxide ions. So I've added 8 because here we have 8 hydrogen ions so that they can form water, right?